Hi! Today's DIY is driven by the following. I need a nice light source for my videos and I have a broken LCD monitor laying around. Can you see where I'm going? Yeah, that's just to cover my back. Make sure you know what you're doing. As I'm planning and documenting the various projects I'm working on, I will need to take close-up pictures of electronic parts or components, and a good light source is key. You can buy some soft boxes or LED light panels that are providing a uniform light source while preventing from having hard shadows. However, I'm a DIY person and I thought I could build one using the backlight from a broken LCD monitor. To summarize, an LCD screen is made from a liquid crystal panel placed in front of a uniform light source. Most of the time, a broken screen is only the liquid crystal panel which is broken, but the backlight part we're interested in today is still functioning. And look how bright it is! Here's the problem. Monitors are usually going in sleep mode if no input signal is detected, and the backlight will turn off. We need to find a way to control this backlight manually. To do so, we will need to analyze how the backlight is controlled. Let's start by taking our monitor apart, remove the LCD panel but keep the backlight, and set the power and the logic board apart for further analysis. If you're familiar with common designs, we can easily locate three main parts of the circuits. The switching power supply, converting the mains voltage into various rails of DC voltages for the rest of the board. The logic and video processing side, which hosts the main controller. And the part that is of interest to us today. I'm referring to the high voltage generation side for the cold cathode fluorescent lamp. Yeah, that's the long name for the couple of tiny neon tubes on each side of the screen that creates the backlight. Let's start by finding the datasheet for the all-in-one LCD controller, which happened to be a common chip from Genesis, the GM2621 series. Once we have the proper datasheet, let's start looking for keywords related to backlight. As expected, we can find P-bias on pin 49, which is described as panel backlight enable. We should also look for a PWM signal that controls the brightness. Yep, that PWM again. If you want to know more about PWM, please check my previous video covering the subject. And here we go, PWM on GP04. If we're going back to our chip pinout, we can see it's conveniently placed right beside the backlight enable pin from earlier. Cool, so what did we learn from this datasheet? We discovered that there's a pin to enable the backlight and one to adjust the brightness. Good, let's try to locate those pins then. I will overlay the pinout from the datasheet and match the direction, thanks to that little dot on the lower left corner. Here they are, colored with some red Sharpie. Now, let's follow those traces and confirm they're going to the backlight inverter section. It's alternating between the top and bottom layer. Yep, it's hitting the red driver chip. We can also shine some light through to confirm, just because, well, for no reason, but how cool is that? Alright, time to take our oscilloscope and confirm our signals. We'll use this lower location as it's more accessible. Time to plug the monitor. Whoa, have you seen that? Let's replay this a bit slower. Yep, the PWM signal comes just before enable, something to keep in mind. Now what? Arduino. For the code, nothing crazy. We will have a potentiometer as an input for brightness control and two outputs, enable and PWM. Oops, remember we said the PWM started just before enable. Let's correct this. We should now cut the trace coming from the chip, find some ground and plus 5 volt to power the Arduino, and connect our new enable and PWM signal somewhere on the tracks. Then secure the wire with some electrical tape. Time to put it back together and give it a go. Not too bad. The brightness doesn't render properly due to the angle of the camera. I was very excited to try shooting something. I placed the screen on some support and started testing. Okay, my setup could use some improvement, but it's a good start. I used a microwave plate motor placed a piece of foam on the top of it, and a random board. After comparing my basement's regular lighting, the desk light, then our new panel on the top, I think we're getting somewhere. Alright, I must admit this is not my first attempt. I've already done this mod with a 56-inch TV. I call that my virtual window, as it has provided a huge amount of light in my basement for the past couple of years, and I can even control the brightness with the remote. In conclusion, we just used an old broken LCD monitor, an Arduino, and a potentiometer to create a nice, pure white, powerful light source. But you could create a nice backlight for a photo frame or whatever creative application you could think of. Hope you enjoyed the video. If you liked it, please leave a comment or a like, and if you'd like to see more, please consider subscribing and leave some suggestions.